this is the review for the piecewise function unit. There's 4 parts to this review. There is graphing, which is part 1, which we're gonna do first. So it says fill in the table below with the key points for h of x and then graph. All right, so we have h of x. We'll start here with -1. That's the first equation that we're gonna look at. All right, and for -1, that's a constant function, and that is a ray. I can tell it's a ray because there's one number in the domain. Because it's a ray, I'm only going to need to plot that one endpoint. However, remember we said when it's a ray or a nonlinear function, we need to plot as many points as possible to fit on the grid. So I'm going to plot, since it's a constant function, I'm only going to plot the endpoint because that one will be really easy to graph. But I'll need to know that for x of -2, that's going to be a closed dot, right? And it's a ray, so as the numbers go smaller, we're going to have an arrow, and the output's going to be -1. So we're going to have a closed dot at -2, -1. Then again, remember, this is a horizontal line, that's a ray. So I'm going to just draw that line out and make it a ray. That's an easy one. You really only need to plot the endpoint there. Next, I have x squared. X squared is non-linear. Okay, so this one's non-linear. And since it's non-linear, on my table, or at least on my graph, I need to plot all those x values from the domain -2 up to 2. I want to plot points for all of those values. So you can type that, if you need, that function x squared into your calculator, and then look at the table. Okay, we're plotting all these points from -2 here to +2. So 4, 1, 0, 1, and 4. Okay, now at -2, I have an open dot. At +2, I also have an open dot. That's going to be a segment that's connected between those two dots. So I'll plot -2, 4 with an open dot, -1, 1, 0, 0, 1, 1, and 2, 4. So I have that segment connected, but remember I had to plot all those key points because it's non-linear. Finally, last segment here, or last piece, I'm sorry, that is a linear function, right? So -x + 1 is linear, but this is a ray. There's only one endpoint. So I'm going to need to plot at least more than one point, as many points as will fit on the grid. So I'll just plot the endpoint of 2. We know it's going to be a closed dot, and it's going to be a ray. And I'll do, how about I do 2, 4, and 6? You could do 2, 3, 4, whatever floats your boat. So if I put 2 into that function, I'll have -2 + 1, which is -1. If I put 4 in, I'll have -4 + 1, which is -3, and then -5. Right, so I'll have 2, -1 has a closed dot, 4, -3, 6, -5, and I could continue that pattern down here if I needed to, connect those to make our ray. So that's your piecewise function. Now let's talk about the domain and range of the whole graph. The domain and range can be kind of tricky. When I look at the domain, let me use a highlighter here. I have an arrow on the left, and that arrow connects all those x's until -2. Now that segment stops, but since it's a closed dot, there's a value at -2. It connects up here, and I have these x's till I get to +2. At +2, I have a value down here, and I keep going for all these x's. So all the way across the x-axis, I have a value of x. So my domain goes from -infinity to infinity. I can put any x value into this function. The range is a little different. The range here, I start at the bottom, -infinity. Ooh, understand color. Start at -infinity, and I go up here until -1. Right? Then you can see there's a little gap right here. Right? So my first part of my range goes from -infinity up to -1 with a closed bracket. But then I have a gap there until I get to this value of 0. So I'm going to join that together from 0, and the highest I get is at the maximum of 4, but those are open dots, so I put a parenthesis. All right, that's the first one. The next two, I did not give you tables, so you will have to make a table if you need. All right, so here's my piecewise function. Let's start again with the first equation. So for that first equation, I'm going to make a table on the paper. Now, if you are on my board here. If you do not want to write down a table on your paper, that's okay. You can copy it straight from your calculator. All right, so my first table here, I'll just call it table 1 for equation 1. I have an array, and I have a nonlinear function. Because it's array and nonlinear, I need to plot more than just that one key point at 1. So let's go to my calculator first. Let's review how to do absolute value. Remember, we hit math, arrow right to number, and then click enter on the absolute value. So I'll have x plus 2, arrow out of the absolute value, and you'll have plus 5. So when you graph it, that's what the graph's going to look like. And I want to plot all the x's less than or equal to 1. So when I look at my grid here, 1 has a point of 8, and it looks like I can plot all the points down to -7. Those will all fit on my grid from -7 to 1. So if you need to, let's copy that down here. So I'm going to write all those values on my table. But if you wanted to just copy them from your calculator, that's okay too. All right, so I'll have 10, 9, 8, 7, 6, 5, 6, 7. There you go. All right, at 1/8, I'm going to have a closed dot, and this is going to be an array. So I'm going to connect all the points and put an arrow on the end. So 1/8's up here. -4. Oh, I didn't do that right. I plotted at -1. Let's start at 1, +1. Here we go. There. Okay, then back up 7, 8, 9. And then I'll connect and put my arrow. That's my first piece. Now the second one here, 3 minus x. This is linear, and it's also a segment. So the nice thing about this one is, you only need to plot those 2 endpoints. Right? I only need to find values for 1 and 3, because it's going to be a segment with an open dot at 1 and a closed dot at 3. And it's a line, so I just will have to connect them. So when I put 1 in for x, I'll have 3 minus 1, which is 2. 3 minus 3 is 0. So if I plot 1, 2, I'll have an open dot. 3, 0 will have a closed dot, and I can connect those. That's the next part. That one was fast. Now the last one here, I'll make one more table for. And on my table, my third table, I again have array and nonlinear. Alright, so because it's array and because it's nonlinear, I need to use my calculator again. So let's type the function 2 square root of x minus 3, arrow out of the square root, and type +6. Okay, here's what the picture is going to look like. And we're going to graph from 3 larger. So let's find the points that are going to fit here on my graph. It looks like 3, 4, and 7 will work. So the rest of those I wouldn't do the decimal. So 3, 4, and 7. That'll be at 6, 8, and 10. All right, and again, I have an open dot at 3, and it's a array. So I'll connect those and then make an arrow. So let's see, 3, 6 has an open dot, 4, 8, and 7, 10. And I'll graph my square root graph here. So look like that. All right, last little bit, we have to do our domain and range. My domain here, I have an arrow from the left. So that goes from -infinity. And it looks like, I'll use my highlighter again here. My arrow is going from the left. It looks like at 1, I'm connected here, so that's okay. I continue to 3. Again, I'm connected to continue the graph out to infinity. So my domain is, again, all real numbers. The range The lowest y value is at 0 here. I go 0 up to 2, but then I have a gap. So my first part of my range is just from 0 inclusive to 2 non-inclusive. And then I pick up that range again, right, highlighter, right here at 5. And then it looks like I go up to infinity. So I'll join in again at 5 to infinity. And that'll be your range. All right, one more problem for part 1. Graph this piecewise function. Again, I'm going to use my calculator to help me. So the first equation here, I'm going to make a table. And again, if you don't want to make a table, that's okay. You can copy it from your calculator. I have a nonlinear function, which is also an array. So I need to plot as many key points as possible. So let's go back to our calculator. I'm going to have my negative, parentheses, x plus 6 squared, then plus 5. Here's what the picture will look like. So I need to plot, my domain is x is less than negative 4. So when I look here, let's go back to negative 4. It looks like the points that are going to fit on my grid will be from negative 4 to negative 9. Those should all fit on my grid. So let's copy those over. So we'll go from negative 9. Okay. And when I plot those points, I'll have negative 1. All right. Now this is going to be an array. I'll have an open dot at negative 4. And when I connect those, I'll have an arrow going to the end. So I'll have negative 9, negative 4, negative 8, negative 8, positive 1, and negative 4, 1 here. And that's going to have an open dot. So when I connect these, I'll have an arrow. That's the first piece of my graph. All right, the second part should be a little nicer here. I have a constant function. So at that constant function, that is linear, and it's a segment. So I really only need points at negative 4 and 2. Those both actually have open dots, so we'll connect those with a line segment. The constant is negative 4, so that is the output for both values. So plot the point negative 4 with an open dot, and negative 2, negative 4 with an open dot, and then connect them. Oh, positive 2. I'm sorry. I got it wrong. Whoa. Try one more time. Positive 2, negative 4. There we go. And that's your segment. All right, last one here. Let's grab the blue. So for this last one, I have an array again, and it's nonlinear. So because it's array and it's nonlinear, I'm going to use my calculator, and I'm going to plot all the points bigger than 2 that are going to fit on my graph. So here I will have 1/2 parentheses x minus 4 squared minus 8. Here's the picture. And let's figure out the points that are going to fit. So we start at, this is a bunch of fractions, let's see, bigger than 2. So it looks like I'm going to fit from 2 up to 10 here will actually all fit. So take a minute, my calculator is fractions, 7 over 2 is 3.5 though. I think they're nice enough fractions that you can get. So we'll plot all the points from 2 to 10. All right, so let's see, I'll have negative 6, negative 7.5, okay, we'll have that. So at 2, I'll have an open dot again, and an arrow going to the end. So let's be careful here when we plot this. 2, negative 6, open dot. 3, negative 7.5, right here. 4, right here. 4, negative 8, negative 7.5, negative 6, negative 3.5, 0, 4.5, and 10. So if you connect those, make a ray, and that is the other part of your graph. So here's my domain and range. When I look at this domain here, I'm going out to the left. When I get to negative 4, I have 2 open dots. So there is not a value at negative 4. So if I use interval notation, I can say my domain goes from negative infinity to negative 4. Then, if I go back to the highlighter here, I pick up at negative 4 and I go until 2. There's also 2 open dots at 2. So my interval, that domain is only from negative 4 to 2, non-inclusive. And then I actually have one more piece. I'll join together right up here, the highlighter. Again, I pick up at 2 and I go out forever to infinity. Now there's another way you can list this. Right, I can do that interval notation, or I could use set notation and say I can use all the x's. I just can't use negative 4 and 2. Those are the only x values that have holes or no value on my graph. Either one is fine. Now for the range, let's take a look at the range here. Use this color. So I actually have an arrow over here. So that arrow is going down, which means I'm going from negative infinity, continuing up. I'm still within this graph here, right? So I at least have a value all the way up to 5 here. But notice from this graph, I go up to infinity. So that means my graph goes up forever. So my range is from negative infinity to infinity, or all real numbers. All right, there's your video for part 1. Check back if you need a video for any of the other parts.